Hi, I'm IdeaNexus, and this is my channel, YouTube channel, about board gaming, gaming, and computer science. Sometimes about just gaming, and sometimes just about computer science. Today, I'm going to continue talking about a game I introduced in my last YouTube video, Vector Racer. In this game, you control a little racer on a grid, a graph paper. You can play this game with just a piece of graph paper and a pencil and paper. Your little racer is going to move along the track, building up inertia, trying to control its velocity, and hopefully get around this track that you have drawn. So it's a creative game, this track that you have drawn to get across the finish line. And so today, I'm going to show you a JavaScript version of this pen and paper game that I made to run in a web browser. And as we mentioned, this game is a great game for teaching inertia and velocity. So this is the game. You have the ability to load different tracks. I've put some preset tracks in, intermediate tracks, hard tracks. There's also an open track if you want to start from the beginning. Here there is a draw track, which toggles the track into a drawing mode, which allows you to add more track, customize your track, and once you've made your customizations, you can get coordinates, and this produces this kind of barfs out JavaScript code that you can use to load in your own tracks to this JavaScript application, and we'll show a little bit more of that later, which you can then take that code and load it by pasting it in, and there's my little modification. And so just like in the pen and paper, graph paper version of this game, you'll start, your little racer is sitting still, we give it some inertia, and now it's going to move one space automatically if we don't act on it in any way. If we go here, we're going to add a little bit more inertia to it. And now we're moving 2 spaces, 3 spaces, 4 spaces, 5 spaces with a turn, 6. And then we start going to try to slow down a little bit to get around the curve. Am I going to crash? Almost. And boom, we crashed, went through this new wall I made. And before we get into the code, I want to talk just a little bit about what you're seeing here. There's some interesting, some different functionality. As you can see, as I hover my mouse around, the different coordinates light up. And each of these coordinates in programming, these are what we call an object. Each one of these coordinates is its own object, and it is responsible for knowing whether or not it's a track, whether or not it's a finish line. It's responsible for whether or not it's knowing it's a point along the way. And then the second set of objects I'd like you to know about before we step into the code are the paths. So here we had a starting point and an ending point, drew a line between them, a starting point and an ending point, drew a line between them. Again and again, you can see the lines getting longer, and we go around, and so between each XY point is a path. And what we're going to do is we're going to keep a collection of path objects so we can maintain the history, while at the same time having this projected path here. And again, the paths are objects. This path knows whether or not it's a projected path or an actual path, like the one that crashed through here. So now we'll step into the code a little bit. Oops. And put that there. Is that showing? There we go. So this is the index.html for the code. For simple applications like this, I just throw everything into one file. If you're a student learning JavaScript programming, I think it's just easier just to have everything in one place, in one file, so you don't have to jump around between different files. And your code coloring tool, your text editor, in this case I'm using Sublime Text, it's going to know what's HTML and what's not, what's HTML and what's JavaScript and what's CSS, and it's going to color code it accordingly. So this is the total of my HTML, this little section here. Right here is the canvas element. That's where all the magic's going to happen. So that's the HTML element where we're going to draw our coordinates. And up here we have the CSS, which is just used to color up the page and get it organized. We won't be worrying about that. I am using jQuery. It just makes the code a lot cleaner. And then here, the only other external file is this tracks.js, which is referenced here. These are the different tracks. You can see here's the open track, the easy track, the intermediate and hard tracks, and each of these is a collection of coordinates. So we've got a finishes array, and that's going to be the finishing line. We've got our tracks, which is going to define all the green boxes on our track. And then this is the start, where our little racer is going to start. At the top of the JavaScript, there is a set of public variables. These are variables that are shared among all the functions in the JavaScript code. Be careful when using these. It's sometimes frowned upon. In this case, there were just certain objects. It was much easier just to pass them around between the different objects. Is the sound on? Are we in a drawing the track mode? Should I load the track pop-up? Here's our canvas. Then this is the CTX, stands for context. That's what does the actual drawing in your canvas. That could be 2D, like what we're using here, or 3D. In this case, we're using 2D. So it's a flat drawing. The canvas offset, this is important, your offset X and offset Y. An interesting thing about video drawing is in the case of our JavaScript needs to know where this canvas object is in the browser, and then we have to offset our mouse. So when the mouse is hovering around, this way you can see each of these coordinates. This coordinate is telling our JavaScript function, I'm being hovered over right now, and so it's going to turn itself into a highlighted object because it's getting the XY coordinates of our mouse. The browser, our JavaScript code has to know where the canvas is in the browser. Interesting thing is when you get out to the window level, the window has to know where the browser is in the window, and so when the browser is recording mouse clicks and such, it has to know that, and Windows has to know that, and you get into this crazy hierarchy of there's a lot of math and offsets that goes into how your operating system knows where your mouse is, and I always think that's really neat. Getting back to the code, we had our public objects. These are just some functions I tend to use in a lot of my things. We've got the toggle draw track, which allows us to draw the tracks, builds a array of coordinates that have been clicked on to build the track, and then we'll output those into code we can just paste into our tracks.js if you want to add more tracks. This polygon function, I definitely grab this. This is one of the most useful. I got this from crazydad.com years ago, and I've used it so many times. It takes your context, the thing that draws in your canvas object, takes the X and Y coordinates of where you want to draw a polygon, takes the radius, how big you want your polygon, how many sides you want your polygon, and then outputs whatever polygon you ask for, and it's just incredibly useful, and I use it so much. Finally, we have here we have our coordinate object. This is each of the XY coordinates in each block in our track. So this is the instantiator, our constructor. It generates, these are all the default properties. By default, it's going to not be track, it's not going to be a finish line, it's not going to be start, but here we have all these set properties. So if we know we can set highlighted, projected, track, finish line, and define this coordinate as this kind of object. Finally, we have a draw. So the coordinate is responsible for drawing itself onto the canvas. And it knows, I'm a highlight, then draw yellow. I'm a projected path, make the color lavender, and this global alpha, give me some transparency to make me kind of a ghostly appearance. Am I a finish line? In that case, draw me a triangle and make it red. Is it a track? Is it start? And then go ahead and render me as the coordinate. Render me onto the canvas in the appropriate XY coordinate. The other interesting thing the coordinate has, it's got a is point inside. So the coordinate, you give the coordinate an XY position, and this coordinate will reply to you, yes, this XY point is inside of me as a block. Is point inside projected. Little fun thing here. Sometimes in programming, especially when drawing on a canvas, there's a lot of math involved, and I don't feel like doing the math, so I have this fudge variable and a more fudge variable to kind of, through some experimentation, was able to figure out, okay, yeah, yes, I am inside the projected path. Finally, we have I'm going to keep saying finally. Additionally, we have a path object, and we're going to have an array of path objects. The path draws itself. It knows whether or not it's a projected path or a committed path, projected path being a ghostly lavender, committed path being a highlighted yellow to draw attention to itself. Now here's an interesting piece. This is the Bresenham algorithm, and what it does is this algorithm returns all of the points from within a straight line. So we've got our starting position and our ending position, and then I want to get all the XY coordinates between those 2 points. And that's really important when knowing whether or not we've gone through the track, whether or not we've crashed, or whether or not we've crossed the finish line. There's a Wikipedia article on this algorithm. I did not prepare to speak about it, and I probably don't even really understand it at this point. I just don't. Fun fact about programming, you don't always understand the code you paste into your application. We have a draw path between coordinates. This is maybe not the best named method, but what this is doing is it's going to get the starting and ending points. It's going to then look using the Bresenham algorithm from the get points from a straight line. It's going to say, have any of these points gone through a coordinate that is track? If so, then the user has crashed. Has any of these points gone through the finish line? If so, then the finish line has been crossed. Has the user crashed? Then tell them they have crashed. Crash. Is the finish line crossed? You won. And how many clicks? The length of the paths. How many path objects have we in there? Do we have in there? So a goal you can have when playing this game is to see how fast you can complete how few clicks, just like in golf, how few hits does it take to get across the finish line. Now we're getting to the finalies. Finally, we have a handle mouse click. What happens when the user clicks on the canvas? Well, we're going to get the mouse click sends an event. That event has a X and a Y, and you'll see there's a client X and a client Y. I'm the client. This is my mouse clicking on the screen. Get those XY coordinates. Figure out get the coordinate that has been clicked, and set it to the appropriate. Kick off the appropriate functions within it. Finally, mouse hover. This is what allows us to highlight the coordinates as we go through them. Then there is the draw grid. This takes all of the coordinate objects. I got this how to draw the grid. I got from a user CodePen.io from a user named Cthulhu Hoop. Awesome username. I love that. In this case, we're going to take our big array of coordinates and we're going to lay them all out using the wonderful code that Cthulhu Hoop wrote. And we finally, we got to load when the document ready, kicks everything off, gets us a new game, finds out where is our canvas, get the context from the canvas, where is the canvas, offset X, offset Y. There's a resize canvas, however, I have not instantiated this. There's also a window event, add event listener, also commented out here. If you resize this browser window, you're going to break the game. Normally, with a lot of web applications, it's not a problem to handle the user resizing the windows. In this one, I just haven't had the time to get that working right. So let's go back, knowing all of that. Let's go back and we'll give it another try. So we have these coordinates know they're finish lines. These coordinates know that they are track. We kick off, handling mouse clicks. As we move our mouse around, each of these coordinates knows it's being highlighted. See if we can get around. I'm going to try and be careful this time. I very rarely make this race, so I'm going to crash again probably. Oh, we are making a straightaway. Oh, it's complaining to me that I clicked an invalid coordinate, and now here's where I'm going to crash. And crash. Oh well. But that is Vector Racer. We have our array of paths. The path, in this case, all the projected paths went off the screen and into the track, so the browser, we don't need to click any further to know we've crashed. And if you're interested in this, it is checked in. I will put the link down in the comments section or the description below the video, and thank you so much for turning in. Thank you.